So okay, we will be modeling a single column footing here. The information are given here. The footing is at 10 feet by 10 feet and the depth of the footing is 24 inch. So let's go to the save. After opening save, we will see a window like this one. So after go to file, new model, and there are lots of methods by which you can model this. So we will be doing a very simple method in this video. So go to blank, and first of all we have to define materials and sections. So go to define materials. So our material is concrete of 4000 psi and steel 60,000 psi. So these things are already predefined in safe. So this is 4000 psi and this is 60,000 psi. So we have nothing to do here. So we will go to the section define. So go to define slab properties, click add new property. So this will be footing 2 feet 24 inch actually. So and this will be from slab to footing and thickness will be 24 inch. Make sure thick plate is on. So okay, and we have to also model the column here, that is a 12 inch by 12 inch column. So for that we will just copy it and we will name this as stiff. We will model the column as a stiff element. So and from footing we will see like this stiff, and this will be 24 inch as well. And make sure this is thick plate. So okay, then okay, after that there are lots of methods of modeling. So we will be using a very simple method. So go to draw, then draw point. For that click this point and then close this one, select object, then go to draw, quick draw areas around points, this option. So our column was basically 12 inch by 12 inch. So we will model that first. So there is a stiff actually. So it's stiff. There is 1 feet by 1 feet, and we will click this point, and the column will be drawn. After that, select footing from strip, and the dimension is 10 feet by 10 feet. So click here, and the footing should be modeled. After that we have to apply the loads. To apply the loads, select this object and select this point, the inside point, and go to assign load data point loads, and we have to select a dimension, the size of load for punching shear, and the dimension will be the column dimension of the column. So here our column size is 12 inch, and by that's why dimension also 12 inch. So the gravity should be the dead load for our model was 250 kip and the live load is 220 kip. So the dead load is 250 kip. There is already a negative sign here, so we don't have to put the negative sign before the number. Then okay, and we have to select it again, and similarly we have to assign the live loads, rotate live load, and it will be 220 kip, and this will be also 12 inch by 12 inch. So okay, our load is applied. Now we have to define the subgrade modulus. Now what is subgrade modulus? Subgrade modulus is basically the ultimate pressure divided by the allowable settlement. The the ultimate pressure is basically the allowable pressure into the factor of safety, which was used to calculate the allowable soil pressure, divided by the allowable settlement. For a single footing like this, the allowable settlement is normally 1 inch or 25 mm. So 1 inch is converted to feet, and result is in a pound per feet cube. So we copy this and come to save. Select the footing surface, and the edge will be green after selecting. So go to assign support data soil properties, and there is already one, so we modify this and just change this value 162,000 pound per feet cube. Keep an eye on the unit. This is compression only, and okay, and you will see a lot of plus signs here. If you go to the 3D, you will see a lot of fixed supports here, kind of. So our load is done, our subgrade model is done, and now we have to define the load combinations. So go to define load combinations, and we will use the add default combinations. For now we will be ignoring the long term and the initial combinations, so keep okay, And let's have a look inside this combination. What are this? So go to modify, and this is actually the only dead load, so we don't need it, we can delete it. So this, the second one is the dead load plus live load, so we rename this dead load plus live load. This will be, this rename will be very helpful in future. So the second one, this is 1.4 dead load, this is the design combo, and this is modify. Go to modify, and this is 1.2 dead load and 1.6 live load, and this is a strength design actually. So our combination is done. Now we have to give the run analysis. For that we have to save it. Actually we name this 3, and if you don't see a control line like this means that your modeling is not properly done. So the contour diagram will be similar to this one. So we have to check that if the deformation is within the allowable limit. So our allowable limit is 1 inch. So you can see the maximum of 0.21 inch. So it is okay. So now we go to the design section. For that we have to unlock, and we have to draw the design strips. Go to draw design and draw design strips here. As this is a 10 feet with footing, and the strip will be at the middle of the footing, so the width of the strip will be 5 feet in each side. So we select this as 5 feet only, and draw a line from this midpoint to this midpoint. By pressing right click we go to exit and select the B strip here, and just click from here to here, and our strip is drawn. So now we go to run analysis and design. So here again we can see the deformation is within the limit. So now go to display, show punching shear design. So if this ratio is within 1, that means your design is okay. But it is if it is more than 1, then the depth is not sufficient for the punching shear. So we can see at the this is very, very close to 1, so we can actually neglect the 0.002 term. So if you want to increase the depth, just unlock the model, go to define, slab properties, footing, modify, and just increase the depth a little bit. I'm increasing by 2 inches, so okay, and hit analysis and design again. So go to display, show punching shear design, and now you can see that it is 0.87, so it is within the allowable limit actually. So now if we want to see the reinforcement, go to design, display, go to display, show slab design. As this is single footing, we will be mainly concerning about the bottom bar, so we can ignore uncheck the top bar, and you can see the both layers if you want to. You can also watch by single layer at a time and hit apply. Let me close one so you can see. So this is our reinforcement issue, and it is showing that bottom it is 0.629, 0.65 inches square per feet. If we if you click here that total strip, then it will show you the total strip, and it is 6.5 inches square. And if you show the number of bar using number of say 6 bar, so it is showing that unit 15 number 6 bar actually. So there are a lot of options if you have a look at this. So this is it, our modeling, and if you go to the layer B and apply, this is also same 15 number 6 bar. So that's it.